Hey everyone, so welcome back to another Prism Caribbean video, and today we'll be going through um, another example with regards to inverse functions, and we'll be moving on to the topic of composite functions right after, right? So once again, I'm your tutor Jordan Jaffa, and we're going to start off with inverse functions. So yes, yeah. So inverse functions. This example tends to come quite a lot, hence why I wanted to go over this example in particular, or this type of example I should say. So let's say we are given a function f of x is equal to 3x plus 2 all over x plus 2, right? And they say find the inverse of this function, right? So the first thing we do is just as the rules before, we let y equal to the function, which is y is equal to 3x plus 2 all over x plus 2, right? And then we interchange the variables. What in this case means is that we change x to y and y to x from this equation here, of course. So that will mean x is equal to 3y plus 2 all over y plus 2. From here, everyone should be understanding what has occurred so far. Just simply following the rules. If you want, you can pause the video here and work along so that you can find the inverse of the function. Or if you think you might need some help with it, you can stay along with the video. So the next step we do now is we cross multiply, right? Cross multiply. So it's all will be one line. So we have x into y plus 2 is equal to 3y plus 2. Which will mean when we expanded xy plus 2x, we know we expanded like this, right? Is equal to 3y plus 2. Of course, now our big aim is to make y the subject of the formula. So let's bring all the y's across to one side, right? So let's say xy minus 3y, because we bring the 3y across, is equal to 2 minus 2x. Of course, we bring across the the 2x, which will be minus 2x. We factorize the y, which will be in this case y into x minus 3, because we take out what is common in both, which is y, and we are left with the x minus 3 is equal to, which is now equal to 2 minus 2x. So now we have y is equal to 2 minus 2x all over x minus 3. That's it, right? And of course we write on our answers f inverse of x is equal to 2 minus 2x all over x minus 3. Again, to go on from this point here, we factorize the y, we expand the brackets to have, because we cross multiplied of course, to have xy plus 2x, which is equal to 3y plus 2, right? And then we will have now xy minus 3y is equal to 2 minus 2x, because we brought across the 3y to make it minus 3y. And then we factorize the y out, which will give us x minus 3, right, multiplied by y is equal to 2 minus 2x. And then we make y the subject of the formula, and when we carry across this, since this is related by multiplication, it will be across division. So this will leave us with f inverse of x is equal to 2 minus 2x all over x minus 3. And that's the answer. So, yeah. So that's it with that. Let me just show you all another question which sometimes may come in the exams, right? Sometimes they might ask find x when, let's say, a function f of x is equal to minus 2, right? And let's say we use the same function when they say f of x is equal to 3x plus 2 all over x plus 2. Well, we know f of x is equal to minus 2, so we input it is equal to 3x plus 2 all over x plus 2. Remember, you want to find x, which are these values here. So of course we cross multiply, right? Again, cross multiplication is a very vital step we need to learn with this topic. So we take the minus 2 and we multiply by the x plus 2, right? But we put in the brackets here, and we make it equal to 3x plus 2. We expand the bracket, minus 2 into x, and minus 2 into 2, right? And when we expand this, we get minus 2x minus 4, right? And then we have it equal to the 3x plus 2. Now we want to find x. So the best option is to put all the x on one side and all the other variables, which in this case are just the constant numbers, on the other side. So we're going to go and put the numbers on the left hand side and the x's on the right. So you'll have the minus 4 minus 2 is equal to 2x plus 3x. So this will be minus 6 is equal to 5x, which would imply minus 6 over 5 is equal to x. And that's it. So of course we know f of x is equal to minus 2. This is given in the question here. And we have the function f of x is equal to 3x plus 2 all over x plus 2. So what we do is that we take the function, right, and we input the minus 2 in place of it, of course, and make it equal to the function itself, as we have here. This is the function itself, right? Then we cross multiply because we want to have it all in one line to solve for x, because that's the question. So we have minus 2 into x plus 2 is equal to 3x plus 2. So we carry across on the other side, put the x's on one side and put the other variables on the other side. We then solve for x, when we found x is equal to minus 6 over 5. So we have therefore x is equal to minus 6 over 5. Right? If you need to slow it down, pause the video, slow the video down, and make sure you understand this, because this is tested quite a lot. So now we're moving on to the next topic. Composite. Oop, I didn't write that properly at all. Composite functions. Right. So a composite function has many forms, right? And it is quite important that we know how to, it's quite important we know how to identify a composite function for not only exam purposes but general purposes when practicing questions. So as soon as we see a question which asks to find things like g of f of x or f of g of x, or even f of h of x, g of g of x, f squared x, and once it has more than one variable in it, we know it's a composite function. And many students tend to be shy about composite functions. They tend to think, it's a very hard topic, when I believe it's probably one of the easiest topics, or one of the easiest topics to grasp. So we're going to go off easy. Of course, with practice, you can only get better, right? So let's say we have a function f of x is equal to 3x minus 4, and we have g of f of x is equal to x squared minus 3. Sorry, this is not g of f of x, this is g of x. And let's say they ask us to find, then I'll bring back that word, f of g of x. F of g g of x, right? There's a very, very simple technique for this. Simply isolate the functions. We have f, that's our first letter, and we want to have g of x now. So we input g of x into the bracket. So now we have f, and let's say now we know g of x is equal to x squared minus 3. We simply input it, right? So now we have a function, f into x squared minus 3. What it simply states, where you see x, input this variable here, right? This is x, right? So that will mean we have 3 into x squared minus 3 minus 4. This 3 and minus 4 obviously came from here. We need to input the function from here, right? We have f of, well, this is basically x. We have f of x is equal to 3x minus 4, so we input x as x squared minus 3 from here, right? So this will be, once we expand it, 3 into x squared, which will be 3x squared, minus 3 into minus 3, which is minus 9, and then we have minus 4. And we solve it, and we get 3x squared minus 13. Oop, that did not come out good. Minus 13. And we say, therefore, f of g of x is equal to 3x squared minus 13. Right? Pause the video or read or rewind the video if you would like to get a better understanding of it. Right? But let's move on to a more practical question. Many times in your exams, they might not ask for you to just find f of g of x. They may do, and they may bring it into another form. Right? So we know f of g of x is equal to 3x squared minus 13. This is based on the previous answer we got, right? So now let's say if they ask, find f of g of 2. Again, what this means is that wherever we see x, put 2. Right? So that will mean f of g of 2 is equal to 3 into 2 squared minus 13. 3, 2 by 2 is 4, minus 13. Right? Again, let me slow down a bit. So we have to find f of g of 2. This means wherever we have 2, well, wherever we have x, we input it to 2. We have an x here. So that means we put the 2. So we place it in, we expand this bracket, and now we multiply it. 3 by 4 is 12 minus 13. 12 minus 13 is negative 1. So therefore, f of g of 2 is negative 1. Right? And we must note that also many times f of g of x is not equal to g of f of x. F of g of x is not equal to f of g of x. Right? Let me repeat that. F of g of x is not equal to g of f of x. Let me show you why. So, we know f of g of x is equal to 3x squared minus 13, right? So, recall, f of x is equal to 3x minus 4, and we have g of x is equal to x squared minus 3. And we want to prove this, right? We already know f of g of x is equal to 3x squared minus 13. So let's now find g of f of x. Again, we isolate the second variable, which in this case is f. So we know f is 3x minus 4. And wherever we have x now, right? we input it into this. So this will be, okay, let me remove that. This will be just equal to, you could say 1 because there is a 1 behind this x squared, into 3x minus 4 squared minus 3. So now we expand this bracket, that being 3x minus 4, 3x minus 4 minus 3, and we expand it. So this will give us 9x squared minus 24x, right, plus 16 minus 3, right, which will obviously give us 9x squared minus 24x plus 13. So we know g of f of x is equal to 9x squared minus 24x plus 13, and we know based on previous calculations f of g of x is equal to 3x squared minus 13, and we know this is definitely not equal. So we just proved that g of f of x is not equal to f of g of x. That's it, right? So the next topic I would like to move on to is, we can maybe look at, in the next video, we can maybe look at either completing the square, or we can move on to some geometry, right? And but that will be it for now, right? Today we took in a lot of work. Make sure and go over the content. Make sure you understand what's going on before you move on, because functions is one area in which you need to get your marks. It's a very, very simple topic. Questions are usually straightforward, and a lot of practice is needed for such topics, right? Once again, I am Jordan Jaffa, your tutor for Prism Caribbean Math. It has been a wonderful session, and I do look forward to seeing you in the next video to come. Take care.